Hello, welcome to another video from the conscientious biologist Ben Gallagher. This is the 9th one overall in the Ecology series, but really it's the second in the human impact pair of presentations that look at how we as humans are having a major impact on the environment and the planet as a whole. This one focuses on one part of that, which is global warming. Now, this is such an important topic and something that everyone really needs to know a lot more about. This is suitable for GCSE level. At some point in the future, I may make a more detailed presentation on this topic, but this one covers everything you need to know for GCSE and gives you a really good grounding in global warming. As always, please do subscribe to my channel if you haven't done so already. I've also got a Facebook page now, so if you search for the Conscientious Biologist on there, there's a lot more information that will help support your course. So let's throw the big question up there first. Global warming, is it real? Okay, you may hear in the media and the news, you may even hear some world leaders and politicians saying that global warming and climate change is a hoax and that it's fake news. Well, it absolutely isn't. And first off in this presentation, I just want to present you with some information to try and show that and try and make my point. So here's a graph of a load of data that was taken since records started, since they began back in about 1880. Okay, now what you've got there in this graph, if I just explain to you what you're looking at. Over on the far axis over there, you've got the temperature deviation from an average. So you look at where I've just put that yellow average, where it's 0.0. That's kind of the average temperature over this entire period that's represented on this graph. So you can see that as the kind of middle point. Okay, what this graph is then showing are for each year, whether the temperature was down, below, in blue, or whether it was above that average in red. Now, you only really need to glance at that graph to see very obvious patterns. Over there on the far side, it's all blue. Closer to me, it's all red. That should be really obvious what that means, but let's pick it apart a little bit. Let's look at that first section that I've just put that yellow bracket onto. It's all blue, almost all blue at that point. That means in all of those years from 1880 up to kind of 1935, 1940, it was colder than the average for that last 140-year period. So those were not necessarily what we could class as cold years, but colder relative to the last 140 years worth of data. Now, what is also scary is if you consider the average for that time period, for what's in that yellow bracket, well, the average would obviously be significantly lower for the average just of that kind of 50-year period. So the deviation from the normal would be less because the average should be lower. So this graph is even slightly artificial in making you think those years were colder than they were. They were potentially just the normal, the average. So everything else should be even hotter after that time. But certainly we can look at that time period and say those years were much colder than what we're used to at present day. If you look at the next time period that I've put in a bracket there, so this is kind of a mid period here from kind of 1935-ish heading up to about 1970, 1975. Now look at what's happening there. The years kind of stabilize a little bit. They're roughly the same kind of height. The red ones, the blue ones kind of balance out. You could flip them back and forth. There's some relative stability going on there. But it's clearly a period of change. Now I'm going to pick out a few points on this graph for you. Let's look at what I've just put in a circle just there. That little bunch of years relative to the years previous, which if you look were all blue, suddenly jump up really high. And that's in the time period kind of late 30s, early 40s. It's the Second World War. That peak in temperature, those years being warmer, reflect the massive increase in industry that happened around the Second World War to provide all the necessary things for the machine of war, all the bombs, all the guns, all the bullets, all the everything. Huge amount of extra industry, huge amount of extra heat being put out into the planet. So that's why you've got that odd big bunch. If the war didn't happen, you could kind of take that bunch out because they stand out as a bit of an anomaly on this graph. Now, given we've said about the Second World War, we ought to kind of think about the First World War as well. And if you look back at the graph there, you might look back at the bit around the First World War. So you're kind of looking 1916, 17, thereabouts. You're not seeing a same red peak. But actually, if I put a little circle on there, you can see that those years that correlate to the First World War, look, the white is higher, the blue is less. Those years were warmer than the average of the other years around them. So war and industry clearly is doing quite a lot to warm the planet up. Even so, let's move on to the more present day stuff. So look at all the years there from sort of 1975. And you might remember from the previous presentation that 1975 marked a global population of 4 billion. Since 1975, the population has gone up to the 7.8 billion that we have today. So almost doubled. So that very short last bit on the scale there is representing a massive, massive doubling. 4 billion extra people coming onto the planet. That presumably must have some impact. But just look at the years. Look how red it is. Look how steep that slope is going up. It's currently June in 2020, so we don't have all the full records, but it's certainly looking like 2020 is going to be the hottest year on record. So that red line at the side here is probably going to go up and be even higher and become the topmost point. Now that's a very obvious trend for anyone to spot. And if I mark a trend line on this graph in blue, you can see there, it's a very definite slope. Global temperature is increasing. So global warming, is it real? Yes. And it's very, very serious. Think about why it's so serious. The thing that people always come to when we talk about global warming, we talk about the ice caps melting. Billions and billions and billions of gallons of water melting and going into the oceans. That's not only destroying habitats for things like polar bears that are shown on this picture, but all that water is going into the oceans, which is going to make the sea level rise. If the sea levels rise, everything on land that is at or close to sea level is going to get flooded. And you think about where most of our major cities are. They're on the coasts, they're on rivers, they're on ports, because that's how we could move goods around. You think about London on the River Thames, you think about New York at the side of the Atlantic Ocean. Major, major cities that will be gone if sea levels rise too much. And it will only take a couple of meters of rise and they will be gone. So it's going to have a massive effect on sea levels. If you're dumping all this water in as well, it's going to change your oceanic patterns. If you look at the picture up there, those are showing all the oceanic patterns, all the streams of water and how the heat exchanges around the world. Now, we have a reasonably good climate in the UK because the Gulf Stream brings warm waters up from sort of Central America, brings it across the Atlantic and brings relatively warm waters to our shores. Things on the same level of us, if you go across sort of parts of Canada, parts of Russia, they're under snow because they don't have these oceanic currents bringing warm things around. So there could be major, major changes at various places on the planet. So even though it's global warming, if the Gulf change shifts, the UK could get covered in snow and could get much, much colder. And this is where lots of people get confused with global warming. We're talking about the average temperature of the planet, not individual places. But because of these shiftings in oceanic currents, there's massive impacts on the weather and whether it brings snow or not. Over the last 10 years or so, there's been a massive increase in huge weather events, like things like hurricanes, cyclones, tornadoes, earthquakes, tsunamis, because global patterns, weather patterns are shifting because of the weather changes. That's causing lots of knock-on effects. And of course, another major effect, while some places may get colder because the distribution of heat can change, a lot of the planet is going to undergo desertification, become deserts, because it's going to get too hot for things to grow. The habitat isn't going to be hospitable to plant life, which of course means the animal life will die as well. So global warming, is it real? Absolutely is. Is it serious? Incredibly. The only debate, and I don't really even like using the word debate, is whether global warming is human driven or whether it's part of a natural cycle. So that's what we're going to start to look at now. So we know that the planet is warming up, but let's talk about why it's happening. So if I put on here a diagram of planet Earth, and we'll surround that Earth in an atmosphere. Now, just before anyone complains, I've drawn the atmosphere on here to totally the wrong scale of planet Earth. If I were doing the atmosphere to scale with my diagram of Earth, it would be a very thin layer of atmosphere. The atmosphere is incredibly thin relative to the size of the Earth. I've massively exaggerated it just to make it more obvious for this diagram. But the atmosphere is a really, really important thing, because what the atmosphere helps to do is when heat comes to Earth, it doesn't immediately radiate back out into space, which means it can hold the heat close to the planet to keep the surface warm, to allow for life, to allow liquid water to exist basically, which is one of the fundamental requirements for life. Now at night, when the planet is away from the direct source of sunlight, that heat can radiate back out into space, which is why it gets colder at night. Now, as long as the heat arriving to Earth from the sun is equal to the heat leaving, then the global temperature is going to remain constant. That's the kind of ideal situation. However, what we've got is a situation where we've got a huge amount of additional carbon dioxide and greenhouse gases that build up in our atmosphere, so I've now changed it to sort of greyer and slightly thicker, which insulates the planet. It's literally like the planet's been wrapped in a blanket. Think if you get cold, you might put a blanket around you, you might put a jumper on to keep you warm. It traps the heat inside. And that's exactly what this does to the planet. Note I've dropped those arrows down because those arrows for the heat radiating out are much smaller now, because with that insulating layer, far less heat can escape and radiate back out into space. So we've now got this situation where the heat arriving is greater than the heat leaving. And if you've got more heat coming in than you can get rid of, then of course global temperature is going to increase. Now what that means is we have something called the greenhouse effect, because it's like we're wrapped in a blanket or trapped in a greenhouse. The heat can come in, but it can't get out very well. So this is where you get this term, the greenhouse effect. The greenhouse effect is the theory that seems, all the evidence seems to show that that's the reason why global warming is happening. But of course that throws up the major question, is where is all the extra carbon dioxide coming from? That's what we'll look at now. So let's quickly run through the carbon cycle, because carbon dioxide is a key part of that. You should have watched the presentation on this already, so I'm going to go really, really quick. If you're not familiar with the carbon cycle, please go back and watch the carbon cycle video, because it's a really, really important biological concept. But we've got carbon dioxide in the air. Carbon dioxide can be taken in by plants through photosynthesis, and they trap the carbon in glucose. Glucose, which has got 6 carbons for every molecule, C6H12O6. Now, of course, plants also do respiration, so they can put the carbon dioxide back into the atmosphere. Again, if you can't remember photosynthesis and respiration, go back to the phase 1 videos. It's in the bioenergetics playlist, and you can watch all that stuff about photosynthesis and respiration. So you've got one cycle there, photosynthesis and respiration. But of course, producers can be eaten by primary consumers, which also do respiration. They in turn can be eaten by secondary consumers as we move up through the trophic levels. Secondary consumers will also respire. All of living things will eventually die, which means when they decay by bacteria, fungi, detritivores, those 3 things are going to do respiration of their own to return the carbon molecules back to the atmosphere as carbon dioxide. You've also got a kind of extra bit to the process of when things die. If they don't decay over millions of years, they might become fossil fuels, coal, oil and gas. When you burn those, the carbon molecules that are in them get re-released back as carbon dioxide through the process of combustion. Now, of course, combustion as well might be natural. It doesn't have to be by fossil fuels. If you've got a forest fire, then any of those things there, the plants and the animals, could burn, could release carbon dioxide back into the atmosphere. You've also got things like volcanoes, which are basically a massive crater of fire. So you've got combustion, they're releasing carbon dioxide as well. So that combustion bit can cover a wide area. But in nature, what should happen, all of these things should be in balance. So that carbon dioxide level up there should always stay the same. Now, why there's a lot more carbon dioxide in the atmosphere seems to be because of 2 major things. The first one is that we as humans have massively increased that combustion arrow. Over the last couple of 100 years, which is terrifying, just a couple of 100 years, we have burned up millions and millions and millions of years worth of fossil fuels. It took millions and millions and millions of years for those fossil fuels to form, from living things that lived millions of years ago. Okay, millions and millions and millions of years to form, a couple of hundred to burn them and send them back up into the atmosphere. That's obviously a massive imbalance. And the reason for all that extra combustion is industry. Since the Industrial Revolution a couple of hundred years ago, factories have been pumping out extra carbon dioxide from the combustion of fossil fuels to produce energy for manufacture. Now we need, really, as a human species, we've come to depend on all of those technologies. Okay, I'm talking to you through a computer, over the internet, through the medium of electricity. You know, we need all that energy to live the life that we've got used to. But there's a price for that. We have to get that energy from somewhere. We, for the last few hundred years, have been getting it by burning fossil fuels. We need to start looking at other energy sources, solar, wind, geothermal, all those things, to try and replace it and reduce that combustion arrow. Okay. The other major thing that we've messed up on the carbon cycle here is the photosynthesis part. We've cut down huge amounts of the Earth's forests. We've removed loads of the plant life. It's estimated, but this is a good estimate, it's on solid data. It's estimated that an area the size of a rugby field, slightly more than actually, about 1.5 acres of rainforest is cut down every single second. That's now, whole rugby field, every second disappearing. At that rate, it's been calculated that we would get through the entire world's forests in 100 years. There's 100 years left of forest on this planet if we keep cutting it down at the same rate that we're currently doing. Now that's just not sustainable. We can't keep doing that, because those forests are what do a huge percentage of the photosynthesis, of removing the carbon dioxide from the atmosphere. Look at this picture. There's only one arrow going down. There's only one arrow removing the carbon dioxide. And that's that photosynthesis one. And we're dramatically reducing that one. It's estimated that deforestation, cutting down all the trees that can do this photosynthesis, contributes to global warming, contributes to the greenhouse gases by about 15%. That's 15% of the increase in carbon dioxide. It's just because the trees aren't there taking it away. The rest is all about the extra stuff we're pumping in to the atmosphere. But that's still a massive, massive amount. So one other thing that I really need to mention, and it's in your syllabus, is this, methane. Methane is another greenhouse gas, because I don't want to leave you thinking that carbon dioxide is the only contributor to global warming. Now, you don't need to know a lot about methane for your GCSE, but there is one key fact that I want you to try and remember, that the effect of methane as a heat insulator has been calculated as 86 times stronger than carbon dioxide. That kind of means it's 86 times worse for the planet. When it gets up into the atmosphere, it's a much bigger insulator. So that makes methane a massive contributor to the greenhouse effect in global warming. Now, you don't really need to know much about why there's this increase in methane. There's lots of reasons. One example is that mangrove swamps trap huge amounts of methane, and they're being destroyed by humans as well as we make room for more habitat. Lots of methane is trapped in ice sheets, and as they're melting because of global warming, they're releasing methane. But actually, one of the key contributors are cows. Because cows, when they eat their grass, the digestion is done by bacteria in their stomachs, and those bacteria release methane. That methane comes out as cow farts, and cows fart a huge amount. They produce massive amounts of methane, and that methane goes off into the atmosphere. Now, you could argue, well, that's nothing to do with humans. Cows are natural things, but consider the number of cows. It's us as humans that started to keep cows and farm cows for meat and for dairy products, for milk and cheese and things like that. So because of that farming, because of humans, the population of cows globally is way, way higher than it needs to be. And certainly as the human population has increased, we find more and more and more cows. So kind of cow population has increased along with human population, which means the production of methane indirectly is caused by us as humans, we've talked about. So let's start on the obvious point. The planet is getting warmer. You've seen the data for that. The increase in temperatures correlates, and note I use the word correlates there, I'll explain why in a second, The increase in temperature correlates with increased atmospheric carbon dioxide and methane. Correlates because we can't exactly directly 100% say that increased carbon dioxide causes global warming. We know it causes insulatory effects. We know that the planet's warming. It seems very obvious that the two go together, but it's a correlation. There's an increase in carbon dioxide over time that seems to exactly match the increase in temperatures. Now that strongly supports the greenhouse effect theory that it is that carbon dioxide that is causing the global warming. The correlation is certainly very, very strong. It seems extremely likely that humans are the main cause of the elevated carbon dioxide levels, which means we have a responsibility to slow the effect of global warming. And that's just in the hope we can reverse it and save the planet as we know it. We don't need to worry about saving the planet. The planet will survive quite happily. It's whether we can survive on the planet in the direction it's going. The planet will shrug this off. It will recover. Whether we are changing it in a way that means the environment is no longer useful for humans to survive on it is a whole nother thing. Now, there are lots of things you can do, and there are lots of humans that are doing loads of things here. This is my absolute hero. I think he's the greatest person on the planet. This is David Attenborough. David Attenborough is a big campaigner for global warming. Look him up if you're interested in this. Look up some of his videos on global warming. This next guy, this is Al Gore, ex-vice president of the United States. He was Bill Clinton's vice president, but he's done huge amounts for publicizing global warming. He wrote the book called, I think it's called The Uncomfortable Truth, but it's a book and a series of lectures on global warming and looking at how humans have impacted on that. That really brought it to the forefront of a lot of people's minds, and he's been in massive battles with industry, especially in America, to try and reduce their carbon dioxide emissions. And then more recently, you've got this girl who I just think is absolutely fantastic. This is Greta Thunberg. I'm sure you've seen her on the news. A huge climate change activist who's really mobilized a whole new generation, your generation, to try and do better than my generation and generations before us. It's not too late for my generation. We're trying to change and do all we can, but it's going to be mine and really your generation that can really drive reducing and hopefully reversing climate change, and you can be part of the solution. So that's the end of this one on global warming, but there's so much more information out there. Please do go and look into it a bit more. There's only one more presentation to go in the Ecology series, and the Ecology series is the last series, the last playlist in phase 2. So please, from here, go on to Ecology 10, Farming and Sustainability, and then you're done. That's pretty much the end of all your course. So good luck with that one. I'll see you on that one. Please do subscribe to my channel if you haven't done so already. Like this video if it was useful. And I do now have the Facebook page, so please go on there for extra information and extra resources. Thank you.